So we are live, guys. Am I audible and visible to you? Yes, we are. Hello, everyone. Welcome to the next episode after a nice. I hope all of you had a safe and happy Diwali there. So after Diwali, we are back again to studies. And before we go further, like the usual statutory warning, I want you guys to stay at home and stay safe. All right, stay at home and stay safe. Maintain social distancing, like this guy here. Like the must stay away from everyone. This is a tough time for everyone in the world, not just you guys. So this is the time you have to maintain social distancing, stay at home, stay safe, and crack IIT-JEE using India's largest platform, which is Unacademy. India's largest online platform, which is Unacademy. Yes, so get this plus subscription using the code NSS1 to get unlimited benefits and the best of Unacademy. We'll be discussing about this as we go further. All right, so this is how the app will look. Nice, two semicircles, one green, one blue. You can install that right away. And a little about me. Hola amigos, I am N Srikant. I did my BTech from IIT Kharagpur with an AIR of 385. I've been guiding you guys for the last 5 years. You guys call me human calculator. Well, we'll know why. And I'm a Sunrisers fan. It was good while it lasted, and DC is equally marvelous, if not better. Yes, I'm a huge DC fan. Joker ka big fan hu main. So anything you'd like to say or put or comment, just put it in the comment section below, and like the video, share this video, make this video viral. This is Let's Crack JEE channel in English. Okay, this is for all those guys who have trouble understanding Hindi. Like most of the channels have Hindi medium. So hello Saket, hello physics. Hello Saket, hello physics, hello everyone. Good evening. So this is a channel for you guys who have trouble understanding Hindi, and I'm teaching you in English here. All right. So today we are going to discuss the next episode, which is magnetic effects of current, part 4. We will be discussing a shortcut to Biot-Savart's law, which is Ampere's circuital law. All right. So just give me one moment. So all of you know the basics, right? Like the Biot-Savart's law, all of you know. Due to a small DL conductor, DL current carrying wire, a DL element, this is called as current element. The magnetic field was found out to be mu naught into DL cross R by 4 pi R cube. Where R is what? R is the radius vector from DL vector to this particular point. Understood? From R vector to this particular point, not this, this is the wrong arrow. So this is the DL vector. This is the R vector and this is the DL vector. DL vector will have direction of the wire. R vector will have direction of the radius vector. Hello Sairam Garu, good evening Amma. Alright, so this is called current element. By the way, this small element will be called current element. Or iske we discussed many formulas for this, like for a ring and all we discussed it will be equal to mu naught I by 4 pi R into theta. And for a line we took it is equal to mu naught I by 4 pi R into sine theta 1 plus sine theta 2. Remember where theta 1 and theta 2 are angles made with the vector on either sides, with the position on either sides, and the strength is R. So this is what we found out, the magnitude of vector to be at point B. So this and all we discussed, but there is a much simpler trick to the whole thing. There is a much simpler trick to the whole thing. So one thing we discussed already, this is very similar to electrostatic force. Force is how much? K Q1 Q2 by R square, remember. So similarly, if you take this, you will also get it as mu naught into DL cross R cap by R square. So this is what we'll get. It's very similar to this. Similar, right? So similarly, we have one shortcut for finding out field, right? We have one shortcut for finding out field. What was the shortcut? Shortcut was Gauss law. Similarly, here we have something called Ampere's current law. So we will be discussing about this today. Just like Gauss law, यहाँ पे Ampere's current law करके there is one very similar concept. Hello Siddharth Yadav, welcome. So just very similar to Gauss law, we have Ampere's circuit law here, but there is little differences. I'll also tell the differences on the go. Okay. So this here is Ampere's circuital law. Ampere's circuital law states that the line integral of magnetic field around any closed path in free space or vacuum is equal to mu naught times the net current passing through which crosses the area bounded by the closed path. So this is exactly thoda reverse of Gauss law. Okay. Yes, it is visible to you. It is not disappearing. Message got retracted before Siddharth. Everything else was visible. All right. So how is it similar or different from the previous Gauss law? In Gauss law, what did we have? In Gauss law, we had areal integration, areal integral, and we took total charge inside the area. Q was inside the area. But in general, in life, how will current flow? Current will flow infinitely. From one end to the other end, we will take infinite wires. We will take infinite stuff. Here, all of these are infinite wires. All of these are infinite wires. मतलब सब एकदम बहुत दूर से they are coming like this. The wires are coming through a particular Gaussian like Gaussian surface. We will have Ampere loop. In that Ampere loop, like this particular thing is Ampere loop, which is also given a particular direction. Okay, Ampere loop will also be given a particular direction. So because it will cover in a full circle, it will make a full loop. This whole thing will be a wire. This is a line. This is a line. It is not area. In Gauss you have area. Here you will have lines. So you can say line integral is the main topic. Let's do line integral matlab total field across the entire line. You just add the field across the entire line, integrate it with the length. That will be equal to mu naught into the current inside the line. Current inside, this is the current inside the line. Inside the line. And all this line integral means you will draw a line instead of a sphere. Instead of a sphere, you will have line. And instead of the total charge inside this surface, we will have current flowing through the line, the area inside the line. Simple. In Gaussian surfaces, you will have total charge inside the volume of the surface. Whatever charge is there inside the volume of the surface, that will give you the total field, right? Similarly here, whatever line charges are there inside the area of line, inside the area of the line, whatever line charges are there, that to sum of all the charges will be the this thing, mu naught into summation of line. Now for line, this is the Gaussian Ampere circuit law. It is very similar to Gauss law in a lot of ways, but different also on these particular aspects. All right. So now let's get a little closer into this. इसमें ये जो loop जो होता है, this whole loop is called as Ampere's loop. Just like Gaussian surface, it's a surface in Gauss. Here it is a loop. Because you are taking a closed circle, you are taking a closed circle, or you are taking a closed square, or you are taking a closed triangle, or anything you are taking, it is a loop because it contains only length, and that length will surround the area. Understood? Similarly, a surface will surround a volume, a line will surround an area. Getting it? Oh, that I didn't get, Siddharth. I only got this first message, the message which got retracted. So just check into it, na? All right. So I hope this is clear. Ampere will have a loop instead of Gaussian surface, or Gaussian surface will cover a volume. Similarly, a loop will cover an area, and in that area there will be some currents flowing in. This is one way of representing it. Another way of representing it is take a loop like this. Let's draw a better loop, something like this only. This is the loop, and suppose some currents are going out of the loop like this. Supac. This is I1. This is some I3, infinite currents, and there is one I2 going down like this, one I4 which is outside, I4 which is outside is going out, and I5 which is going in inwards is going like this. Some loops are like this, but these loops are covering inside, they are getting in touch here. This will be X and these two will be A. So this is the diagram in 3D of this. I hope it's clear to you guys. I hope this 3D diagram is clear to you. I will draw it again a little more neatly if you want to. I will draw it neatly. It's okay. तो मतलब कुछ ऐसा है loop है कुछ, and some currents are flowing in through the loop like this. This I3 is going up, so I'll put a dot. I2 will go down. तो यहाँ पे क्रॉस लगा देते हैं. When it's going up, again we'll put a dot. All of them you see from the top. All right. So, and then there is one I5 which is going like this, and one I4 which is going like this. It's not touching inside the loop. It is going outside the loop. This will be I3. This will be I1, I2, I3, I5 and I4. We just took some random values like this. So this is how the currents are flowing. Understood? So only these three loops are inside. So Ampere's loop, just like Gaussian surface, will not depend on outer surfaces. So from this we can directly say integration of B across the total length. If the total length will be some L. Integration of B dot dl, we will also take it as B into L, but that is for symmetry. Integration of B dot dl will be nothing but mu naught into summation of I. Okay, this is only the Ampere's circuital law. Understood? So what is summation of I here? It depends on the direction you are taking it. If I am taking it to be in the anti-clockwise direction like this, if I take anti-clockwise direction, what is the positive direction? Direction is upward, right? For anti-clockwise direction, you will get everything is outward. So outward will be taken as positive, and inward will be taken as negative. That's all. So in anti-clockwise direction, where the loop will be anti-clockwise, you can take the thumb direction will be outwards towards you. So in that particular case, positive will remain dot and negative will remain cross. So I can directly write total summation of just like their positive charge and negative charge. We added all the positives, we subtracted all the negatives. Here also anti-clockwise may whatever current is outward will be positive and inward will be negative. So we can directly say B dot dl लाइन इंटीग्रल में भी लूप ही यूज करते हैं, विल बी इक्वल टू म्यू नॉट इनटू I1. What is the total current? So we'll add all the positive currents, which are I1 and I3. I1 plus I3 minus I2. So this is about Ampere's circuital law. We will discuss more about this as we keep going forward. All right. So this is the basic definition of it. So this is it. मतलब एकदम कोई भी लूप, it should follow symmetry. ठीक है, it should follow symmetry. But any just like Gaussian surface has symmetry. Remember, same way here, Ampere's circuital loop will also have symmetry. It will work based on the concept of symmetry, and in symmetry we have to also understand what is positive, what is negative. Just like in Gaussian we had very good clarity, because positive charges were positive, negative charges are negative. Here Ampere's circuital law, if you take in the direction to be anti-clockwise, then this will be positive and this will be negative, and the field we will take across the entire loop will be outwards. This field is taken to be outwards. Then because the field will be in not outward, sorry, my bad, it will be in anti-clockwise direction. It will be in anti-clockwise direction. The anti-clockwise directional magnetic field will be across the entire loop, will be given by this particular simple example. I hope you understood this. Definitely guys, one more thing, if you like this video, definitely like this video, share this video everywhere, so that everyone in the world can watch this video and maybe learn a lot from this particular event. Like this link between Gaussian and Ampere's is very nice. It's very simple. जिसको Gaussian अच्छा आता है, you can also learn this, and if you are able to follow this, you can automatically get Gaussian law using this logic only. It is pretty cool, right? So yes. So Ampere's circuital law, it is the total magnetic field along a line, inclusive of current inside and outside. So just like Gaussian surface, again, it will have the field along a line. It will have a field along a line inclusive of total. It will have total field, including outside and inside charges, including out and inside currents. So in a loop, if you take a symmetric loop, the current outside also will give you a field there. The current outside, which all depends on symmetry. It all works in symmetric loops. मतलब जहाँ पे भी symmetry, if you are able to find some sort of symmetry, you can just go for the loop. You can draw a loop along the line of symmetry, and you'll get the answer. Symmetric loops means you will have to use line of symmetry. Like in Gaussian surface, we'll use surface of symmetry. Remember, every surface which is symmetric, for a point charge, it will be a sphere. Similarly, here for a point, for a single line, it will be a circle. वहां पे जैसा sphere था, यहाँ पे it will be a circular loop, will be symmetric about a single charge, single current. For a single current, the circuit will be the symmetric loop. Okay, and direction of magnetic field is perpendicular to the loop imagined. It's not perpendicular to the loop imagined, it's along the line. This is wrong. It is along the loop imagined. So you take a symmetric loop, the direction of field will be along that loop. Understood? So it along the loop means there will only be two types. Two types. One will be anti-clockwise and the other will be clockwise. Clear, guys? So in a loop, in a direction of magnetic field in this loop will be either clockwise or anti-clockwise based on the total current in the current carrying. Simple. एकदम ये अगर ऊपर है तो we will get direction of magnetic field will always be anti-clockwise here, right? Which is what we already derived. If you take anti-clockwise loop, we will take this as positive and this as negative. Similarly, if you take same thing, if you take current flowing like this, if you take the anti-clockwise loop, if you take anti-clockwise loop or you take clockwise loop for me. Same example, I will take clockwise loop. If I take clockwise loop here, simple पहले simple का लेते हैं. So clockwise loop, if I take direction to be like this, in a clockwise loop, this will be negative. The positive charge, the outward direction will be negative and the inward direction will be positive because you just loop your hand, you know the standard direction, right? उसी direction का intuition डाल दो. If the total current is outward, then the field in the loop will be. So this is what. If total current is outwards, sum is outwards, then anti-clockwise. So total current will be when the total current is outwards, then the loop will be anti-clockwise. The field will be magnetic field is anti-clockwise, right? If the total current is inwards, then you will get field will be in clockwise direction. Remember this. If the field is x direction, you will get the field to be clockwise. We took that only as standard representation. We will continue with the same representation where inward direction, total current is inwards or it is going into the page, then the magnetic field will be in clockwise direction. So in clockwise loop, everything which is inward will be in a clockwise loop. Sorry for the bad handwriting, मैं एकदम flow में चला गया था. In a clockwise loop, everything which is inward will have positive direction and anything which is outward will have negative direction because we know everything which is going inward will give positive clockwise field. I hope you understood the logic behind it. Is it clear to everyone? मतलब जो direction anti-clockwise में है, when you're taking anti-clockwise, you move your hand in the direction of anti-clockwise direction, then the thumb will show outward. So outward will be positive. If you take clockwise loops, you take clockwise, the direction of thumb will be inward, so inward will be positive. So this is the only difference between Ampere circuit law and Gauss law. Gauss law, the surface direction is not mattering, but even there we took, no, actually, due to negative charge, the direction of field will be inward. Inward field is negative, outward field is positive. Same logic here. I hope everything is clear in a straight. So now we'll just take the application of Ampere's circuit law in a straight line current carrying wire. So simple example, we will take a straight line current carrying wire which is carrying current outward this way. We'll take a simple straight current carrying wire outward this way. For this, what is a symmetric line? If you observe symmetric line, symmetry will be in a circle. In a circle. Circle. Right. The symmetry will be in a circle. So in this circle, what is the loop? What is the field due to this? I'll take anti-clockwise direction. And यहाँ पे I कुछ ले लेता हूँ. Alright. So I'll take it a distance R. बहुत simple सा logic है. I will derive the basic equation of infinite wire using this logic. At a distance R, if the current I is happening. What is the length of the loop? Total length of loop will be equal to 2 pi r, and the field will be symmetric throughout. So I'll directly write integration of b dl will be equal to b into 2 pi r. All right, and this will be equal to mu naught into I inside, mu naught into summation of I. What is the summation of I inside, which is equal to mu naught into I in this particular case? Since anti-clockwise loop is there, I will take I is positive because the direction of current is also this. So आप दोनों को equate करो बस. Ampere circuit लो integration of B dot dl will be equal to mu naught into summation of I. From this what do we get? B into 2 pi r is equal to mu naught into I. So B will be how much? Mu naught by 2 pi into I by r. Remember, this is the formula we already got. Ekdam simple sa must. This is a very nice explanation for it, guys. I hope it's clear to everyone. If you definitely like this explanation, hit the like button there and follow this, share this everywhere. So this is how Ampere circuit law can be used in symmetry. Similarly, मान लो दो close wires है, एक ऐसा है, एक ऐसा है. This is I1, this is I2. So what the symmetric loop, again we can take it to be symmetric like this in a circle at a distance r. So what will we get? B into 2 pi r will be equal to mu naught into I1 minus I2. यहाँ पे मैं I am taking the anti-clockwise loop here. So B into 2 pi r will be equal to mu naught into I1 minus I2. B will be equal to mu naught into I1 minus I2 by r in the anti-clockwise direction. अगर इसको clockwise direction मान लिए तो you will get the value to be I2 minus I1. I hope it's clear, guys. If you take it in clockwise direction, it will become I2 minus I1. So similarly, we will take magnetic field due to infinite solid cylinder. मतलब solid cylindrical conductor को हम लेते हैं where current is flowing up in a particular direction. Here we will take three cases. One is when the case 1 is when it is inside the conductor. Case 2 is on the conductor, on the wire. And case 3 will be which is when it is outside the wire, outside the. Alright, so this is the whole concept of it. We are assuming field due to infinite long cylindrical conductor having uniform current flow. Uniform current flow. We'll take uniform current flow for now. We will solve other complicated problems as you go. मतलब और आएंगे eventually. So this magnetic field due to infinite long cylindrical conductor due to uniform current flow we will figure out. Okay. So case 1, case 2 and case 3. पहले हम case 3 को solve कर देते हैं क्योंकि case 3 easy है. We will solve case 3 first. Everywhere if you observe all the cylindrical conductor, the line of symmetry will be a circle. Concentric circle मान. It is a concentric circle. है ना? The line of symmetry will be concentric circle, just like Gaussian surface for a point charge you had sphere, or for an infinite line charge you had cylinders. Remember, similarly instead of areas there you will have lines here. What is symmetric line about a conducting wire, infinite wire? It will be a concentric circle only. No? That is the simple concept behind it. So we will use a concentric circle here. If you observe here at a distance x. At a distance x from the radius is r, the current flowing is I, and the distance is x. So what can we say using this only this single loop? I will use the current 3 here. I will use anti-clockwise direction because यहाँ पे dot है. The current is going up. Current ऊपर जा रहा है मतलब it will be going out. So the magnetic field due to current going outward will be anti-clockwise. So that is why I am taking anti-clockwise loop. तुम clockwise भी लेके इसको minus लिख सकते हो. It will be the same. So due to in case 3 what will I get? B into 2 pi x. So we will write the formula again. Integration of B dl will be equal to mu naught into summation of I inside. So B into dl is how much? 2 pi x will be equal to mu naught into I. So field will be how much? Mu naught I by 2 pi x. If you observe carefully, is this similar to that of a wire of a thin charge? This is same as thin current wire, right? So outside the wire, so you can also come to this inference. So inference को अलग color में लिखते हैं ताकि it look little more wonderful and you guys can enjoy it. Inference क्या है यहाँ पे? ये है कि the cylindrical wire will behave like a thin wire. Outside the radius of the cylinder. So this is the main crux of it, guys. Inference पहले हम this is very similar to, if you observe, a spherical body is similar to a point charge. Spherical mass is similar to a point mass. The same concept here. Any wire which has finite thickness also can be taken as a thin wire. A cylindrical wire can be taken as a thin wire. So this is very useful for solving many problems which can get more and more complicated as we go. All right. So this is the main concept here. And case 2 is on the wire. Case 2 is on the wire. एकदम on the wire क्या हो रहा है? Case 2 on the wire also the same thing is happening. But one thing we know, the radius will be minimum. So radius of the wire, given the radius of the wire is let's take capital R. On the wire, B into 2 pi R will be equal to mu naught into I, because even now the same current is flowing. So B at the junction will be equal to mu naught I by 2 pi R. So this is the case 2. और एकदम third case का भी हम अब we'll do the case 3 now, because case 2 is very basic. Case 1, we will do case 1 now. Case 1 में what is the total current inside? If you observe here, if you take a Gaussian, not a Gaussian, an ampere loop here, ampere loop inside at a distance x. So what will be the current inside? I inside will be how much? This is one very important point which I want you guys to analyze. So I will tell this one for now, but I really want you guys to understand this one. मतलब एकदम बिना देखे, you have to use it logically. So when there is uniform current, we discussed there is uniform current flow. So in this case, we can say the current density will be same. Current density will be same. And what is current density equal to? The current density will be equal to I by area, right? Remember, I by, in this particular case, it will be equal to I by pi r square. It is current by area of flow. So current density, I will use the concept of current density here. Current density will be I by pi r square. So that is the current density of every current which is flowing out. So now current inside will be equal to J into area of loop. हो गया ना simple. The current inside will be equal to J into area of the loop, which is equal to how much? J into pi x square. Awesome sauce. So now we'll apply this. So integration of B dl will be how much now? Integration of B dl will be equal to B into 2 pi x. And this is the current flowing inside. So we'll directly apply B into 2 pi x will be equal to mu naught into I, which is J into pi x square by, this is it, J into pi x square. And what is J? I by r square. We didn't define J here, so we'll directly write it as mu naught into I into pi x square by pi r square. So pi cancel हो गया, तो इससे क्या आ जाएगा? B into 2 pi x will be equal to mu naught into I into x square by r square. तो इससे फील्ड आ गया हमें एकदम मस्त वाला इक्वेशन, mu naught I by 2 pi into x से एक बार चला गया by r लिख दो x by r. So let me write it as x by r square. This I will write it in a little nice way. Mu naught I by 2 pi r into x by r. So if you observe carefully, this is increasing linearly. It is mu naught I by 2 pi r is the maximum value you can get. So this is case 3. Case 3 का field कितना है? This one we get. So graphical analysis ये होगा. This is how we'll get the graph. I'll draw all the ones. Case 1. It is mu naught I by 2 pi r into x by r. So slowly as it keeps increasing, it is field is proportional to r. If you observe x or r, whatever x, we will take it as x here. So I will take it in x. X is equal to 0. X is equal to x is great. So initial case b will be proportional to x, and at case 2 it is the maximum value at point 2. At 2, value of field will be equal to mu naught I by 2r, which is 2 pi r, which is also equal to this at x is equal to r. So at x is equal to r, it will be maximum because x is equal to r के बाद wire नहीं है. So once wire is over, the story will be over. It will behave like a thin charge, thin wire. But before that, it will behave like this. So eventually, it will slowly increase till it reaches this particular point. This is the maximum value, and it is present on the wire. All right. And at case 3, field will be proportional to mu naught I by 2 pi x. So this x is independent of r, so it will behave, it will continuously keep decreasing as a function of b will be proportional to 1 by x. I hope it's clear to you guys. If you like it, definitely hit the like button. तो ये point है कि at this particular point at 0, now field at 0, if you substitute x as 0, what is the value of field you're getting? The field here will also be equal to 0. And it is slowly increasing along the line with b is proportional to x by x. What is the slope of this line? Slope of this line will be equal to how much? By logic, no, y is equal to mx. Y will be equal to mx. B will be equal to mu naught I by 2 pi r square into x. This whole thing will be m. समझ में आ गया एकदम? y is equal to mx plus c वाला equation है. Y is equal to mx plus c is 0, so directly we can write y is equal to mx as the equation. Y axis is b and x axis is x, तो दोनों को equate किया तो slope of this line also we got off. It's just like that fun. Hello Adya Ahuja, welcome. Long time since I've seen you. So this is a mathematical representation of magnetic field in a very simple way. This is Ampere circuital loop, by the way. So if you already know it, good, we will have some problems today. Otherwise, I am trying to explain the concept of Ampere's loop. So across the entire time here, the magnetic field will be linear. This is linear increase in magnetic field. I am pretty sure you have seen this in a lot of places. You've seen this in gravitation. You've seen in a sphere. You've seen this in a sphere, spherical non-conducting charge also will have same lines. तो ये ग्राफ जो है अभी तक, ये ग्राफ जो है अभी तक it is always usable and it will remain the same throughout if you use Ampere circuital loop. Understood? So this graph, get used to it. Already हम तुम लोग पहले जान चुके हो. X is equal to r. It has a maximum value and it is equal to mu naught I by 2 pi into r. And from there it will start reducing because r will keep increasing, x will keep increasing, and x is greater than. That's it. So this is about this. So similarly, if you take a hollow cylindrical conductor, this is a little more complicated. Okay, yes. Hollow cylindrical conductor. मतलब hollow conductor कैसा होता है? It will have current across some parts. Like most of the current carrying parts will have this also. This is also part of it. तो ऐसा होगा जैसे कि यहाँ पे दिख रहा है. From here to here there is current flowing. Current flowing यहाँ पे भी ऊपर ले लेते हैं. So the current here will be inside. यहाँ पे पूरा जगह everywhere there is current inside. Everywhere there is current on this. सब जगह current है. There is uniform current throughout. I hope it's clear. There is current flowing everywhere across the cylinder like this. There is a cylinder. Inside there is no current. Outside there is no current. Only in this particular hollow part there is current. We are taking the radius, inner radius to be A, and the outer radius to be B. Inner radius क्या है? A है. Outer radius B है. So what is, again here also there is current I flowing. Current flow will be equal to I. So here also I will use current density because it is flowing across the entire area. Oh, laptop is gone for repairing. All right, it's okay. So here also, if you observe, the current is flowing across the entire area. The current is flowing across entire area. So we will use areal density. Current density will be equal to I into area. What is the area of this whole loop? If you observe area of this whole loop, this particular, मतलब ये जो सरफेस है इसका एरिया कितना होगा? एरिया जिसका आउटर रेडियस बी है, इनर रेडियस ए है, तो एरिया विल बी इक्वल टू पाई बी स्क्वायर माइनस पाई ए स्क्वायर. Outer area minus inner area, no, simple, which will be equal to pi into b square minus a square. This is how you get area of a hollow, मतलब hollow नहीं, not fully hollow but semi hollow cylinder का area इतना है. So what is current density here? It will be equal to I by area, of course. I by pi b square minus a square. It's the same logic now. All right. So now if you take at a distance from 0 to a, now I'll take case 1 directly. I will directly start with case 1 क्योंकि case 1 यहाँ पे सबसे easy है. Case 1 में it is inside and there is no current inside. I inside will be equal to 0. Must. So field inside into 2 pi x will be equal to 0. So field inside कितना होगा? Field inside will be equal to 0. So this is one more wonderful this thing you can solve. All right, one more very important point you can solve is the B inside, the field inside will be equal to 0. Got it? The field inside when there is no current, when no current is passing, to Ampere's loop. When no current is passing through Ampere's loop, the field will be equal to 0. एक बहुत simple inference है. I think it's already done. I think you already know this inference. But then it's मतलब logically आ जाएगा ना. So inside it's very similar to a shell. This is similar to a shell. So everything has same. Everything is same, dude. मतलब तुम अगर एक बार if you are able to understand spheres or if you are able to understand gravitation of shells or current carrying charges, spheres and all, it will have this same logics here. Logic will remain same, only that here you will take loops, you won't take surfaces. All right, awesome, awesome sauce. So case 1 b inside will be 0 and in case 3 simple. I'll do case 3 also next because case 3 is also easy. I inside will directly be equal to I. कोई करंट डेंसिटी का यूज करने का जरूरत नहीं है. आई जस्ट यूज आई इनसाइड इज इक्वल टू आई. सो आई विल डायरेक्टली लेट बी इनटू 2 पाई x विल बी इक्वल टू म्यू नॉट इनटू आई. फील्ड कितना हो जाएगा? म्यू नॉट इनटू आई. दिस इज आई इनसाइड और ये ऊपर जा रहा है तो आई एम टेकिंग क्लॉकवाइज, आई एम टेकिंग एंटी क्लॉकवाइज लूप्स. ऑल दीज आर एंटी क्लॉकवाइज लूप्स. clockwise loops. So this will be mu naught I by 2 pi x. This is again the same inference we got for a cylindrical. So for cylindrical ho ya hollow cylinder ho, the field it produces outside will remain same. Awesome. बस समझ में आ गया. अब केस 2 पे जाएंगे. केस 2 is where it gets very tricky. Case 2, I will draw this diagram now at a distance x. This is where you actually have to analyze the whole thing in a much more serious way. तो कलर चेंज, ये क्या, तो कलर चेंज भी हो जाएगा एकदम नेचुरली. इफ यू टेक I try to draw the best loops possible. This is the best loop I can draw. If you find it horrible, please hit the like button. All right, at a distance x. All right. तो इसके अंदर if you observe, the I inside will be equal to j into I inside, j into area inside. Inside area ना. तो बस वही है, इसका वैल्यू a है, the upper value is b and this is at x. So what will this area be? Same like previously, you will get area is equal to pi x square, which is the outer area, minus pi a square, which is inner area. दोनों को मिक्स किए तो व्हाट विल गेट? पाई इंटू एक्स स्क्वायर माइनस. अच्छा, ये तो हो गया. तो नाउ व्हाट कैन वी से? नाउ आई विल अप्लाई एम्पियर्स लूप लॉ. एम्पियर्स सर्किटल लॉ है, इसका नाम लूप लॉ नहीं, बट आई कॉल इट एम्पियर्स लूप लॉ बिकॉज एम्पियर्स लूप तो एक और भी होता है ना. चलो ठीक है. ऑलराइट, एम्पियर्स, एम्पियर्स क्या है ये लॉ, इसका नाम क्या है? आई कीप फॉरगेटिंग नेम्स मैन। एम्पियर्स सर्किटल लॉ, बस एम्पियर्स सर्किटल लॉ भी है। इट्स लाइक लूप लॉ ओनली, करेक्टली अगर बात करें तो लूप लॉ टाइप ही है ये। तो b into 2 pi x will be equal to j into pi x square minus a square। तो b कितना होगा? j into pi into x square minus a square by 2 pi x। अब j कितना है? j का वैल्यू हम सब्स्टिट्यूट ऑलरेडी पहले कर चुके हैं। j का वैल्यू इज इक्वल टू i बाई पाई इंटू बी स्क्वायर माइनस ए स्क्वायर। तो इसको सब्स्टिट्यूट कर दो इसमें, व्हाट विल आई गेट? b विल बी इक्वल टू j बाई 2 पाई एक्स। j को सब्स्टिट्यूट कर दो, म्यू नॉट भी है ना यार, कि क्या कर रहा हूँ? अच्छा अच्छा, ओ जाने जाना। तो म्यू नॉट बाई 2 पे एक्स को पहले बाहर कर देता हूँ, then it will be equal to pi into x square minus a square into j is written as I by pi b square minus a square। तो ये है, एकदम थोड़ा दिखने में लग सकता है बड़ा, बट देन इट इज वेरी सिंपल। म्यू नॉट इंटू आई बाई 2 पाई एक्स इंटू एक्स स्क्वायर माइनस ए स्क्वायर बाई बी स्क्वायर माइनस ए स्क्वायर। दिस इज अ वंडरफुल, मतलब दिस इज द बेस्ट वे ऑफ रिप्रेजेंटिंग इट। If you like it, I'm telling you, definitely don't forget to hit the like button। But this is एकदम complex सा दिख रहा था, but then if you solve it, it has ended up becoming a very very simple problem। All right, no problem। All right, so now magnetic field specific position for thin hollow cylindrical conductor। For thin cylindrical conductor implies B tends to A। इसमें क्या होगा? सिंपल है, बी टेंस टू ए, तो इसमें सब जगह यूज कर लेना जो भी है उसका वैल्यू। सो इनसाइड इट विल बी 0, आउटसाइड विल बी म्यू नॉट आई बाई 2 पाई एक्स। नाउ बिटवीन दिस, एग्जैक्टली at case 2 if you observe, what will be the field when the both are very similar values? उसको देखो, म्यू नॉट आई बाई 2 pi x into x square minus a square by b square minus a square। तो इसमें x is tending to b लिख दो, तो x is tending to a comma b। तो इसमें क्या हो जाएगा? दिस विल बी इक्वल टू म्यू नॉट आई बाई 2 पाई ए एक्स, x is tending to a into b which is equal to r, मतलब ऐसा ही है सिचुएशन। तो लिमिट x tends to 0, this one minus this by this minus this will be equal to 1। This will be equal to 1 times 2 by r। तो इसमें फील्ड कितना आ गया? u naught I by r, because limit x tends to r, x square minus a square by b square minus a square, x tends to a comma b, b tends to a, both of these together, this will be equal to 1। अंडरस्टूड? तो एकदम सिंपल सा हो जाएगा। ये थोड़ा मैथमेटिक्स ज्यादा है, आई डिडंट वांट टू डू दिस राइट नाउ, सो आई जस्ट गेव ऑफ द आंसर। सो इफ यू लाइक दिस, जस्ट हिट द लाइक बटन। सो द ग्राफिकल एनालिसिस ऑफ दिस पर्टिकुलर केस, B इज इक्वल टू 0 इनसाइड, तो मतलब अंदर जो भी है वहां पे मैग्नेटिक फील्ड नहीं रहेगा, बट एग्जैक्टली ऑन द सरफेस इट विल बी इक्वल टू B is equal to म्यू नॉट I by 2 pi r, and from there it will start reducing you just like a single charge and it will work like this। This is very similar to a shell if you observe। मतलब यार सब जगह एकदम magnetism is very similar, it's not very different to gravitation। So that's why I say if you get one you will get everything। Physics में, especially in physics, if you are able to understand one of the many concepts you are learning, that simple logic, the logic of that application will work everywhere। So that is why I feel no one is good at single topic in physics। If you are good in physics, you are good in the full subject। All right, so yes, if you like this, definitely share this video everywhere guys, and a little about Unacademy, crack IIT-JEE, especially in this hard times of corona, with India's largest online platform, which is Unacademy, undoubtedly। So get the Plus subscription using the code NSS1 to access unlimited benefits. What do you get with this Plus subscription? Well, with Plus subscription, you get access to the best of Unacademy. This Plus subscription is your access to the best of Unacademy, where you have daily live classes where you can chat with your educator, engage in discussions, ask your doubts and answer polls all while the class is going on. The live classes there is no delay. Like you can see here, the time of delay which I give to the comments here is a little more. But in daily live classes at the Unacademy platform, you can chat with your educators, engage in discussions. You can send your doubts through images. Pretty cool, that is. Send your doubts, send your solutions all through images, and answer polls all while the class is going on. Everything will happen dynamically. Dynamic representation. So this is one way where you can actually, one place where you can have your doubts cleared in a very effective way. All right. So doubts can be cleared in a very effective way. And not only that, you have structured courses. Well, all our courses are in line with your exam syllabus. All the courses in our Unacademy platform are in line with the examination syllabus. So, and it's already recorded sessions, you will have it. So you can actually have unlimited access to all the teachers teaching all these recorded sessions in the platform at your pocket. So it's like a pocket college. It's like a pocket library. It's like a pocket rocket. Anything you get, you can find it there, and you can study at your own convenience. बाहर इंस्टीट्यूट्स में मेजर इशू ये होता है कि once a teacher misses out, it will be very tough for you to catch on to it. But otherwise, you can have a structure. You can have unlimited access to all the teachers' content. All right. Not only that, you will get live tests and quizzes where you can evaluate your performance with regular mock tests and quizzes and get detailed analysis of your performance. You'll have lots of quizzes there and tests. And like I always say, a quiz a day will keep you ready for JEE any day. A quiz a day will keep you ready for JEE any day. That's the motto of my daily quiz show, which is happening today at 10:30 p.m. Stay tuned, guys. At the app, install the app right away and come to the quiz at 10:30 p.m. Today we have an integer quiz show. Integer quiz show number 2 after the holidays. So it's going to be so much fun. All right. So definitely stay tuned there. So the cost now, let's see, like what Joker says, when you're good at something, never do it for free. Similarly, Unacademy charges a nominal fee for their Plus subscription. The cost of it is 28K for 6 months and 38.5K for 12 months and 56K for 2 years. So if you observe carefully, the price for 6 months and 12 months, if you observe, the price for 6 months to next 6 months is much less. And similarly, from year to 1 extra year, you're getting for 17.5K. So that is pretty cool. That's why if you're preparing for JEE 2022, definitely take the 2-month subscription. Not only that, this is a bumper offer. Amazon offer type है. Use the code NSS1 to get extra 10% off. जो भी वैल्यू है उसका 10% घट जाएगा आफ्टर यूजिंग द कोड NSS1. एकदम स्माइलिंग आदमी को देखो, ही स्माइलिंग बिकॉज ऑफ द कोड NSS1. बिकॉज ऑफ कोड NSS1 ही स्माइलिंग. तो मतलब तुम लोगों को भी अगर स्माइल करना है तो डेफिनेटली यूज द कोड NSS1. द कॉस्ट ऑफ इट विल कम डाउन टू दिस मच. The price, if you analyze 12 months, it comes out to 2,888 rupees per month. Okay, 2,887 rupees per month. This is 32 rupees for physics, chemistry and maths. मतलब 32 rupees में हर दिन you can study physics, chemistry and maths. Similarly, this is 2,300, this is 2,100 rupees per month, which is coming out to 23 rupees per day on physics, chemistry and mathematics. So this is pretty cool, guys. I think you should go for it if you really have the intention to crack IIT-JEE with India's largest platform. Pretty cool. Next, the iconic subscription is for those guys who need help from teachers in their preparation strategy. Most of you guys used to be there like that, taking help from teachers, how to prepare and which chapters you're doing well, which chapters you're not doing well. Now, Unacademy has introduced a personal coach who will give you one-on-one guidance from top exam experts. Top exam experts will be giving you one-on-one guidance, and he will be your personal coach and help you with your preparation strategy. Test analysis, in-depth test analysis will be given based on like which questions you're doing fast, which questions you're doing slow, which topic you're doing better. All these things will be given to you in the test analysis here. And not only that, you will have a study planner where this test analysis will be given to you in a bi-weekly reviews. Reviews will be given to you, and all these will be given in a loop. The personal coach will analyze your tests and give you a study plan in a weekly or bi-weekly fashion. Not only that, you also get all the benefits of Plus subscription already given to you. So मतलब ये सब है तो थोड़ा extra होगा. The price of this is 56K for 1 year and 86K for 2 years. Again, use this code NSS1 to get it for 50k for 1 year and 77,400 for 2 years. This is those of you guys who want to crack 2022. और ये बोल रहा हूँ कोरोना कहीं नहीं जाने वाला है, so this issue will be there for you guys, so definitely this will be there. And not only that, you can use this code for this 1 month, 50,400. The cost of this is 4,200 per month. After using the code, this comes out to 46 rupees per day on physics, chemistry, and maths with a guide. And this comes out to 32 rupees per day on physics, chemistry, and maths. So what are you waiting for? Just go for it, guys. Hit the code NSS1 and you can get awesome discounts. All right. Now for the next question. The next question is, find the magnetic field along an infinitely long cylindrical wire of radius r whose current density varies as J is equal to alpha x. The value of J is equal to alpha x at a distance x from the axis of the cylinder, x less than radius होते हैं, x less than r वाला condition में find out करना. So how do you do it? एकदम let's take a cylindrical, I'm taking the cross section, ऊपर से देख रहा हूँ, the current wire can be like this, ठीक है, the current wire can be like this and the current is going up. I will take, just because it's not given in the question, तो यहाँ पे भी ऐसे करके center से I will take, the current is going out from the center of the loop, current is going out. So what I will do is, now at a distance x in this loop, I want to find the total current inside. I want to find current inside. मतलब inside का current कैसे find out करेंगे? For this you have to integrate the total current, no? Or you can just add all the, so current inside will be nothing but integration of small currents, di. So how do we calculate di now? So I'll take this x current. So let me take the x current like this, the radius to be x. This radius is x. So what I will do each, at a distance x, I will take a small dx element. I will take a small dx element. A standard procedure होता है ना, whenever there is variable current, you have to use this standard procedure. So what is the total area of this? So di will be equal to j at a distance x into small area, into the area. What is the area of this part? Area of this into dA. I'll write this as dA. मतलब थोड़ा technical कर देते हैं, मतलब area अगर इतना feel से नहीं करेंगे, we'll just dA will be equal to 2 pi into x into dx. क्योंकि ये total area जो है, total circumference into thickness. That is a standard procedure when you have this kind of problems. dA is 2 pi x dx. So di can be written as, j is given by alpha x, right? Alpha x into 2 pi x dx is di. So now the integration of this value will be from 0 to x. So what am I integrating? I am integrating across the entire value from 0 to, let me give this value something else. I'll call this some r. r तो बहुत common है, x हो गया, y ले लेते हैं. So integration of this limit should be from 0 to y. So now we can find out I inside will be equal to 2 pi into alpha into x square dx from 0 to, ये वैल्यू कितना, ये बाई x square dx ना, तो x cube by 3 हो गया, तो ये वैल्यू हो गया alpha by 3 into y cube by 3. So what is the field? I'll apply this inside. Now I'll start applying this in the original equation. Original equation क्या है? Integration of b dot dl is equal to mu naught into I inside. So integration of b naught, b into 2 pi y, क्योंकि इसका लेंथ, तो टोटल लेंथ y है ना इसका, अगर ये y है तो टोटल लेंथ विल बी 2 pi y. b into 2 pi y will be equal to mu naught into 2 pi alpha y cube by y cube by 3 बार. अच्छा, b कितना हुआ इसका, mu naught, तो 2 pi कट गया, अल्फा इंटू वाई स्क्वायर. एकदम वाव, सिंगल पेज में सिंपल सॉल्यूशन गाइस. तो दिस इज ऑसम सॉल्यूशन. शेयर दिस वीडियो एवरीवेयर सो दैट एवरीवन कैन सी द सॉल्यूशन. मतलब एकदम सिंपल सा सॉल्यूशन. तो पहले एक y लेंथ तक ले लिया कि बेटे इंटीग्रेटिव यू वांट टू फाइंड टोटल करंट इनसाइड. I inside will be integration of dy from 0 to y. So what is the di value here due to this at a distance x? Total distance will be y again. At a distance x, if I take dx element, the total di will be jx into dA. dA is 2 pi x dx or jx is alpha x. तो इन दोनों को लिंक करने से you will get this value. Awesome solution, guys. So that's about this. All right, now इस क्वेश्चन को हम कैसे सॉल्व करेंगे. This is one killer question again. At distance r inside it, we are asking us, the question asked is find the field inside of this. तो इसमें एक सिंपल सा लॉजिक यूज कर लेते हैं. Alright, so if you take a loop like this and just if you take a loop and maybe just cut the small part of it of thickness b na slit of width b, तो इसमें क्या होगा. So what I can say here is across the entire loop the current I will flow outside and only due to this particular point the current will flow inside. Are you getting the concept? So this is like negative mass. Use the concept of negative mass, concept of negative current, also negative current or negative mass. So this one plus this one, I amount of this plus I amount of this is equal to 0. So if current is flowing up with I and down also with I, total current will be 0, which is exactly what is happening in the slit, which is equal to the current in the slit, right? Current in slit. So what I will do is, so I will write the whole, this diagram will be equal to a full cylinder of whatever radius is there, radius r, plus one slit of width b, thin slit of width b. Thin slit मतलब एकदम plain wire type हो जाएगा. It will behave like a plain wire. But then I'll draw the slit so that you can see. This is slit having width b, and here current is going upwards and here current is coming downwards. एकदम इन दोनों के कारण field total add कर दो, you'll get the answer. So for this you have to find out the current per unit length here. The current acting per unit length. So total current is I. Will be for the across entire length. What is the length of the total thing? 2 pi into r minus b. ये total length हो जाएगा ना, because total length minus the remaining small vacuum. So this is what we will get. Clear? So इसके कारण the total field inside will be this much. So this is the across the entire length. This is the current. This is the current density per unit length. Current per unit length. Now we start solving using both of the individual inferences we got. One thing we know, inference 1. I will call this case 1 and 2. Inference due to 1. Field due to 1 will be how much? 0, because it's a shell. It is a hollow cylinder. हो गया ना एकदम मस्त. And second thing, field due to 2 will be equal to mu naught into I across 2 by 2 pi into r. 2 pi into r जो भी है, हाँ, right, at a distance r from the this edge. So mu naught I into 2 by 2 pi r हो गया ये simple सी option. So mu naught I into I2. What is the value of I2 here? I2 will be equal to width into current per unit length, which is equal to b into I by 2 pi into b, 2 pi into r minus b. ये हो गया. I2 will be equal to IB by 2 pi into r minus b. I hope this is clear. अब इसको सीधा इसमें substitute कर दो. B will be equal to mu naught into I2, which is IB by 2 pi r minus b by 2 pi into तो इसको और नीटली लिखना है तो म्यू नॉट बाई 2 पाई आर हमेशा लिख दो इंटू आई करंट विच इज फ्लोइंग. व्हाट इज द करंट विच इज फ्लोइंग? आई बी बाई 2 पाई इंटू आर 2 पाई आर माइनस बी. So I hope this is clear, guys. It's very simple. It's very straightforward. It is nothing but mu naught I by 2 pi r, and this is nothing but the current in this direction. This is nothing but I2 direction, and the direction of field will be inwards because this will give 0. This will be 0. It will be x direction. I hope it's clear. So this is about current flowing through a hollow thin wall tube having a small break. Now magnetic field due to an infinite plane sheet of charge. ये बहुत important है. The field inside is very very important due to the plane sheet of current. Infinite sheet of current lies in the xz plane. मतलब this is xz plane. ये xz plane है और y axis ऊपर दिख रहा है. The field at any point P on y axis along a line parallel to the xz plane. Parallel to the xz plane, यहाँ पे field कितना होगा? We can take a regular ampere in loop as shown. So in these kind of infinite, like exactly like in surfaces there, when we took plane sheets of charges, we took Gaussian surfaces to be cylindrical or cubical. Similarly here, for a loop, current which is flowing through a sheet, we can define ampere loop as a line, as a rectangle passing through up and below and around both the directions. So here this is that I took the length to be A and the width to be B and B, which is 2B. This is the current density here is given by, let's take the current density of this current charge density is lambda per unit length. Current density will be lambda amperes per unit length. Amperes per unit length. मतलब यहाँ पे जो भी small length you're taking, the total current flowing will be lambda into that whole length. And now let's start solving the problem. The current is flowing inside. So inside के कारण the field here will be outward direction. Field due to field in loop 1 will be how much? B into A will be equal to the total charge B into A. That's it. No, simple. Field here will be B into A will be the answer. And B due to 2 will be how much? B due to 2, if you observe the magnetic field direction, if you observe the direction of magnetic field will always be along this particular direction. ऊपर यहाँ पे होगा, नीचे direction होगा. This is the direction of magnetic field. Direction of magnetic. Now we will come to the very important part. What if the line is perpendicular to the direction of magnetic field? So यहाँ पे this line is like this and the magnetic field is in this direction here, and here the direction of magnetic field is in the opposite direction, and the length of the loop is along this particular direction, and always the angle is 90 degrees. B is perpendicular to DL in surface 2. In second and fourth loops, in fact I will also include the fourth loop to this. In second and fourth loop, 0 because B is perpendicular to L vector. Getting it? So इस loop में B2 and B4 will be 0, and similarly B3 again will be equal to B into A. Getting it? So B again will be equal to B into A. So now what do we know? B1 will be equal to B1. So this is. So along these loops, now if I write integration of BDL across loop 1. So this whole thing is integration of BDL. Sorry, it's not B2. Integration of BDL in 1. Integration of BDL into ये field नहीं है, BDL. B4 and 2 will be same. Because B is perpendicular, integration for B3, integration of B into DL will be equal to B. So now integration of loop 1 BDL1 plus BDL2 plus BDL3 plus BDL4 will be equal to mu naught into I inside the loop. Will be equal to mu naught into I inside the loop. This is the wonderful solution, guys. So BDL, this one was equal to B into A plus B0 plus B into A plus 0 will be equal to mu naught into I inside is nothing but lambda into length. So 2BA is equal to mu naught into lambda into length is how much? Length of this will be equal to BA again. So A cancel हो गया, B will be equal to mu naught into lambda by 2. So this my friends is the solution. आराम से पीछे जाके सामने आके pause करके notes उठा दो. Just copy the entire notes. If you have any trouble, just feel free to ping in the comment section. We can reply to that later. All right. So from this is all you can think of. Like this is the maximum complexity you will be having. So इसको हम कहाँ use करेंगे? We will be using this in a solenoid. We'll be using this in a solenoid. We'll define about solenoid in the coming classes. Solenoid, toroid और ये सब हम next class में we will be discussing them in the coming classes. So this magnetomotive force. Magnetomotive force क्या होता है? Magnetomotive force is defined as the integral of this. The whole value is line integral of the magnetic field, right? So B we can write it as mu naught into H, or you can simply write it is nothing but mu naught into total summation or the summation of area. The line integral of magnetic field around any closed path is equal to the net current passing through the area bounded by the closed path. This is only called as magnetomotive force. Is it clear? So mu naught into H dl is nothing but mu naught into summation of I. So this is nothing but B into dl, no? Integration of B dl. B can be written as mu naught into H. So this is what we will get. Magnetomotive force MMF is defined as integration of H dot dl, which is summation of total current. एकदम सिंपल है. मैग्नेटोमोटिव फोर्स क्या होता है? इट इज नथिंग बट द नेट करंट क्रॉसिंग थ्रू एन एरिया इन ए क्लोज्ड पाथ. मैग्नेटोमोटिव फोर्स वर्ड बड़ा हो सकता है. इट इज नथिंग बट द नेट करंट फ्लोइंग through a closed surface. The net current flowing through a closed surface is only defined as a magnetomotive force for the given closed loop. So I hope you understood it. So now let's talk a few problems on this. The current flows in a spiral of inner radius A and outer radius B. It is a spiral. मतलब क्या कैसा होगा? So it will be like this. I will draw the diagram for you. एकदम wonderful diagram खींच होगा. Inner radius A है और ऐसे करके it will keep looping in, it will keep increasing loops like this. Everywhere it will keep increasing the loops and finally at the end it will come out like this. The inner radius is A and the outer radius is B, and the number of turnings is equal to n. So the number of turnings will be equal to n with inner radius A and the outer radius B. The current I flows in it. I is the current flowing in it. So what is the magnetic induction at the center of the spiral? So we'll take out individual loop and we'll start solving. One thing we know, if you imagine the whole thing like a loop like this, at a particular, so the number of loops here are n. And this inner radius is A and the outer radius is B. So what can we say? Loops per unit length will be equal to n by B minus A. Getting it? So now if I take a small dx element ka loop at a distance x, if I take small dx element ka loop, so in this number of loops in dx length कितना होगा? n by b minus a into dx. This is the number of loops. And what is the field now? Magnetic field will be a magnetic field into 2 pi x will be equal to n times the current flowing inside. No, the n times the current there. तो मतलब चलो लूप का ही सॉल्व कर देते हैं. Magnetic field due to the small dx element will be equal to mu naught into I into number of loops, which is n dx by b minus a. Number of loops. Mu naught I into n by 2r. In this case it is equal to x. तो इसको सिंप्लीफाई करना है. Mu naught I into n by 2 times b minus a into dx by x कितना होगा? ln हो जाएगा. This is equal to, this is db, no? Integrate this whole thing from 0 to b final. So b final will be equal to mu naught I into n by 2 times b minus a ln b minus ln a, which can also be written as ln b by a. तो इसका सिंपल कितना हो जाएगा? mu naught I n by 2b minus a ln b by e. So this is the solution, guys. I hope you like this. If you like this, definitely hit the like button, share it everywhere. This is the field. I hope it's clear to everyone. All right, now for the next one. In a long magnetic cylinder R, the magnetic induction varies with the distance as B CR power alpha. Find the current density as of the wire as a distance as a function of wire. तो इस बार हमें field दिया हुआ है. We are being asked to find out the current density. All right. So inside at every point we already use the same funda. We will use the same funda. I hope we can use this. ये अल्फा एक्स का जो भी सोल्यूशन है, हाँ, तो इसमें क्या आया? डी आई विल बी इक्वल टू आई इनसाइड विल बी प्रोपोर्शनल टू. तो चलो इसको फिर से सॉल्व करेंगे. लेट्स नॉट लुक बैक. तो इसमें आई विल सॉल्व इट यूजिंग डिफरेंट कलर्स. Now at a distance x, if I take dx, at a distance x I take dx element, so current I will take to be current and density to be j. So what will I get? The total current will be equal to j into 2 pi x dx from 0 to r. J into 2 pi x dx. So j will also be a function of time, j into 2 pi x dx. This will be the total current inside. So total current inside will be equal to j into 2 pi x dx integration. So now we will get field is equal to field into 2 pi. We will use the Ampere circuit law now. Ampere circuit law now. Integration of b into 2 pi into dl will be equal to mu naught into summation of I. Or you can also say integration of di. This is also another way of writing it. एकदम हमेशा correct होगा. So b into 2 pi r, small r, no? R will be equal to mu naught into j into 2 pi x dx. So now from 0 to r. So this whole function is a function of, so this is equal to c r power alpha. So अब इसको क्या करूंगा मैं? रिवर्स डिफरेंशिएशन कर दूंगा. आई विल डू डिफरेंशिएशन. डिफरेंशिएशन से क्या आ जाएगा? म्यू नॉट इंटू j into 2 pi x dx is equal to c into r power alpha. I hope this is clear to everyone. So I will send this to the other side. I'll write j to be a function of, I'll write j is equal to k into r power x. ठीक है, r power n लिख दूंगा. तो इसको हम अप्लाई करेंगे. we will get mu naught into k into 2 pi r power n plus 1 is equal to c r power alpha into dx into dr. हो गया ना? ये एक मस्त सॉल्यूशन आ गया. इसमें क्या आ जाएगा? म्यू नॉट इंटू के इंटू 2 पाई r power n plus x, r power n plus 1 dr will be how much? r power n plus 2 by r power by n plus 2 into dr is equal to c r power alpha. So यहाँ से क्या आ जाएगा? n plus 2 is equal to, तो n plus 2 will be equal to alpha. So n will be equal to alpha minus 2. इसको एक और, हाँ, इसको इसको एक और बार सॉल्व करेंगे. जस्ट लुक एट दिस. It's varying as r power 7. So dr, this will also not be there. So integration of this dr. So at this particular point, it is varying as r power alpha, right? So if you do dcr by alpha, so इसको पूरा थोड़ा एक बार cancel कर देते हैं. Let's solve this in a little more simple way. इतना सब कुछ करने का जरूरत बिल्कुल नहीं होता है. So field into 2 pi r is this whole thing. So field is varying as c r power alpha. C into r power alpha into 2 pi r will be equal to mu naught into j into 2 pi r dr. यही होगा. तो अब इसको डिफरेंशिएशन के लिए उस साइड भेज दो. So what will I get? So c into r power alpha plus 1 into 2 pi will be equal to mu naught into j into 2 pi r. Differentiation of this by dr will be equal to this. ये एग्जैक्टली. तो इसमें क्या आ जाएगा? c इंटू आल्फा प्लस 1 इंटू आर इंटू 2 पाई. जो 2 पाई है ये दोनों साइड कैंसिल हो जाएगा. तो आई विल नॉट राइट 2 पाई. विल बी इक्वल टू म्यू नॉट इंटू जे इंटू 2 पाई आर. तो जे का वैल्यू कितना हो जाएगा? c बाई आर. 2 पाई कैंसिल हो गया ना. c बाई म्यू नॉट इंटू अल्फा प्लस 1 इंटू आर पावर. ये जो अल्फा माइनस 1 अल्फा हो गया था, अल्फा माइनस 1. This is the value of J. I hope it's clear to you guys. If you like this, definitely hit the like button. So now for the another question, a thin strip of. By the way, इसको copy कर दो, pause करके copy कर दो इसमें से. So one thing we know here is dB by dr is equal to dB by dr. So हाँ, इसमें एक बार इसको simplify कर देंगे. P into 2 pi r will be the total magnetic flux. I'll call this magnetic flux because it is very similar to electric flux. ठीक है, इसको magnetic flux बोल देता हूँ. So d of B into 2 pi r by dr will be equal to mu naught into ij into 2 pi x 2 pi r. This is the formula we will get. इसको use करने से ये automatically आ जाता है. So definitely pause this video and share this video everywhere. Okay. Now a thin strip of width B carries current I. This width of the strip is B carrying current I. The magnetic induction due to this current at a point P located at a distance R from the strip. Now this is just integration question, guys. This is a little complex integration question. So what I will do is at a distance x I will take dx thickness. And what do I know? Current carrying I across length L. So I will take current density. I will take linear current density. Linear current density. यहाँ पे every time you have this, you have to take linear current density will be equal to I by B across length B. So I by B is linear current density. So dx thickness will have di will be equal to I by B into dx. अब एक current आ गया. So now we just have to find the total field. dB will be equal to mu naught into di by 2 pi x at a distance x. So what will the answer be? Mu naught by 2 pi x into I by b dx. तो इसको mu naught I by b 2 pi b कॉमन ले लो. dx by x इंटीग्रेशन कितना हो गया? From zero, from limit should be from this distance is r and this distance is b, so it will be r to r plus b. So equate the whole value. Mu naught I by 2 pi b into ln r plus b minus ln r. This is coming out to mu naught I by 2 pi b ln r plus b by. So this is the field, guys. एकदम simple solution. Okay, I'll look into it over. So that's about it for today, guys. So definitely crack IIT-JEE with India's largest platform, which is Unacademy. Definitely, this is crack IIT-JEE in English channel. Subscribe to this channel for loads of videos like this in English. That's all for now. Adios, amigos. Don't forget to use the code NSS1 and hit the bell icon to get regular updates of when the classes are going on. And definitely comments, hit the comment section and feel free to comment anything you like. You're all free to do whatever you want. Subscribe, and we have a Telegram link, like button. Don't forget to like it. Don't dislike it, just like it. All right, guys. So that's all for today. Tomorrow we will continue with this with many more problems. And until then, adios, amigos. Until next time, see you.